the exponential functions and the logs of knowing like what was going to happen, say if you changed the base from 3 to 7. So, and you had the idea that these are inverses of each other. So I always think of these first as exponential functions, and then I switch the x's and y's to think of them as log functions because they're inverses. So if I have 3 to the x, that's the red line here, right? Because when I put in 1 into x, then that's, actually, let's make this scale be a step of 1 and go, so we have a perfect square window here. This is we're gonna see everything clear. All right, so now we have it by 1. So when I put 1 into it, I end up with 3 to the first power should be 3. Here we go. 3 to the first power is 3. And if I'm using 7 to the first power, it's 7, right? And then it's going to be, the 7 squared is going to grow faster than 3 squared because that's just 9. So we can see that this function is going up faster than this function. But when we switch the x's and y's, right now, if I switch the x's and y's, when I'm putting 1 in for x, right, I'm getting 7. So sorry, when I switching my x's and y's. So when I put 1 in for y, I'm at 7, right? So this point here is the inverse. It won't let me put the plot on here. I have 7 comma 1, right? That the inverse of that is 1 comma 7. Right, so these 2 points, they're the inverses of each other. And that would be like having 1 comma 3 and 3 comma 1. And if I put both functions on there, now we see it going through. So when I put 49 in for x, right, that's going to be 2 for y. So this one is slower, and this one is rising faster on the y's in relation to the x's. All right, so maybe it'll help to first think about these in terms of exponential and then think about switching the x's and y's to find the log. Let me know if that helps or if you have more questions.